Perfect. So I think I'd start with a brief history of LSD because I think it's quite fascinating the way this drug came to light in the world. So it was first synthesized in 1938 by a chemist named Albert Hofmann, who was working with lysergic acid derivatives in order to determine which ones can be used as a central nervous system stimulant. And then, LSD didn't serve the purpose he needed it to, so he disregarded it. 5 years later, he was re-looking at some of the chemicals that he developed, and he accidentally administered to himself LSD through his fingertips. And this is the first recorded human trip of LSD. And he records his experience as having an extremely stimulated imagination, an uninterrupted stream of fantastic pictures and extraordinary shapes. And this took the world by shock. It was to discover such a potent hallucinogen was something fascinating, and its ability to modulate the psyche. So research focused until 1970 on how this drug can be used to treat things like anxiety, depression, addiction, as well at large doses as an acute model of psychosis. So its potent hallucinogenic effects took the world by storm, and this increased the recreational use of this drug. It became a very prominent drug that people would take for fun, essentially. And this ultimately led to the Controlled Substance Act in 1970, which ceased all the research being done with this drug as well as other hallucinogens. And to me, it's quite absurd that this classification took place because what's a Schedule 1 drug? It's a drug defined as something with no currently accepted medical use and a high potential for abuse. Which, if we look at all the science being done before this classification, it seemed like such a promising therapeutic drug. Slowly, research using psychedelics resurfaced in the world, and there was this renaissance in the 1990s. And research essentially continued and stemmed off the research that was done before the banning and the classification of these drugs as Schedule 1. So some of the more famous and the pioneer research that took place included psilocybin and LSD. And in fact, what they found is that this is the graph I'm presenting to the right. We see that a very early study in this field showed that psilocybin actually decreased anxiety scores. So if we look at this table, we see that the y-axis is anxiety levels, and we see that the black squares is the group that received psilocybin. And conversely, we see that the triangle line are people that received a placebo. But when this group was crossed over to take psilocybin, we see that their anxiety scores decreased. And in my opinion, what's most fascinating about this study is that they show that even 12 months following the administration of psilocybin is that this reduced anxiety level was maintained. So this really shows that a promising effect and therapeutic potential of this drug. Now, very quickly, I'd like to talk about the pharmacology of LSD. Serotonergic hallucinogens take their hallucinogenic effects via the serotonin receptor type 2A, and most specifically in the medial prefrontal cortex. In fact, they've developed drugs like DOI, which is a selective 5-HT2A agonist, and it's proven to be a very potent hallucinogen. Other receptors that it binds to are the dopamine type 2 receptor, as well as the trace amine associated receptor 1, so TAR1. And we see that it binds to these receptors all over the brain, which explains this very vast profile of behavioral effects. Now, very quickly, the medial prefrontal cortex is a very interconnected brain region. So it has a very diverse profile of afferent and efferent projections. It's very implicated in all sorts of behaviors, but most notably social cognition. And in fact, we see in individuals suffering from autism spectrum disorder, we see that they often show disrupted neural activity in the medial prefrontal cortex, which again links back the implication of the medial prefrontal cortex in having regular social behavior. Now, my research focuses on identifying the robust behavioral effects of LSD in mice. So we seek to determine, and the reason it's nice using mice is because it allows us to use this wide variety of established behavioral assays to look at many different things like anxiety or sociability. But the benefit of also using mice is that we can use more invasive procedures that allow us to look at the neural activity and what is actually happening at a biomolecular level. So my research also seeks to understand the mechanism of action of LSD, as well as which neural circuits are implicated. So the first test we performed for this study was the direct social interaction test. And this is a test performed by first putting the test mouse in an empty cage, letting it habituate for 10 minutes, and then putting an intruder mouse inside. And what I'm measuring is how long the test mouse spends interacting with the intruder mouse. And so on this graph here is the results of the first pilot study we did with LSD. And what we found is that 30 minutes or 24 hours post injection of LSD, that this had absolutely no effect on the interaction time. So then we decided to see if repeated administration of LSD would create a change in social behavior. And this would make sense if LSD perhaps requires some neuroplasticity in order to take effect. So the methodology we used was to give a dose of 30 microgram per kilogram per day for 7 days. And then on the 8th day, we performed behavioral assays. And I'll explain the justification of the dose shortly. But what we first found is that this repeated administration of LSD was actually able to increase the interaction time in the direct social interaction test. And I think it's quite powerful to actually see this in action as opposed to just a graph. So to the left here, we see the direct social interaction test in vehicle-treated mice. So these are mice that did not receive LSD. And so the mouse to the right is the test mouse, and we can identify the intruder mouse as the one having a piece of tape on its tail. So as we see, it does interact a little bit, but in general, it just spends a lot of time exploring the cage, but it still spends some time interacting with the other mouse because mice are inherently social beings. And I think the contrast is quite powerful looking at LSD treated mice. So now the mouse most front, the right in front is the mouse that was treated with LSD. And then again, the mouse with a piece of tape on its tail is the intruder mouse. And what we see here is that the mouse spends significantly more time interacting, and it's essentially spends most of the time following the intruder mouse and really spending an overwhelming time interacting with it. The next test we performed was another gold standard in assessing sociability in animals. So this was a 3-chamber sociability test. And the way this test is performed by first putting the test mouse in the 3 chambers apparatus and let it habituate. And then the first testing phase of this experiment is the sociability phase. And what I do here is I introduce an empty cage and a cage with a stranger mouse inside. And what we were assessing is the mouse's preference to interact with a social object. In other words, the cage with a mouse inside, as opposed to the empty cage. And mice naturally spend more time interacting with the cage with a mouse inside than the empty cage. And we see that with this diagram here. And the next stage, which we perform right after the sociability stage, is the social novelty part of this experiment. And in this case, we replace the empty cage with another cage with a novel mouse inside. And we're looking for here is if the test mouse prefers to interact with a novel mouse rather than the familiar mouse. And we see here that mice not treated with anything just naturally prefer to interact with a novel mouse. And what this tells us is that mice naturally have a preference for social novelty. And then we administered the same treatment, so repeated LSD for 7 days. And we'll start all the way to the left. So what we see here is first that, so in black is the vehicle treated mice. And what we see is, as expected, they interacted significantly more with the cage with a mouse inside than with the empty cage. However, when we treat them with LSD, we see that this preference for a social object became more robust. So they interacted significantly more with the stranger mouse in a cage than the empty cage. And this is a way to normalize this data, instead to put it in terms of a sociability index. And we see that this sociability index is greater in the LSD-treated mice. Now in the social novelty phase, we see more or less the same thing. So we see that, again, mice naturally prefer the novel mouse than the familiar mouse, but we see that this preference is, again, more robust in LSD-treated mice. So the social novelty index, again, is greater in the LSD-treated mice. Next, we perform the open field test. And the reason it was important to do this test, maybe first I'll explain what it is. So essentially we put the mouse in an open field for 20 minutes. And what we're looking for is exploratory behavior as well as its locomotion. And the reason it's important to test this, especially when dealing with psychedelics, is because, as I mentioned before, a large dose of LSD can be an acute model of psychosis. And psychosis is one of its main characterizations is having hyperlocomotion. So in order to determine that the dose we are giving isn't in fact a psychotic inducing dose, we would have to see that its locomotion and its exploratory behavior is not impaired or altered. And this confirms that. So we see that the distance traveled or the time in the center or the entries in the center of the open field are not significant. So there's virtually no difference between vehicle treated mice and LSD treated mice. So this confirms our dosing. So with all these sociability results, the next logical question became, what is the neural basis of these changes in behavior? And the way we assessed this was by using in vivo electrophysiology. So we put an electrode inside the medial prefrontal cortex of the mouse, specifically in the infralimbic cortex, and we recorded the neural activity. So what we found is that acute LSD, which again didn't show any behavioral effects, did not change the spontaneous neural activity of in the medial prefrontal cortex. Next, we tested this with repeated LSD, and similarly, we didn't find any change in the spontaneous neural activity, but we did find is an increased bursting activity. So there were more spikes per burst in medial prefrontal cortex neurons, and this has to do with perhaps the fundamental way that LSD takes its behavioral effects. And this is where our research is heading, is to understand why do we see this change in bursting activity, but not its spontaneous firing rate. Now, future directions of my research seem to focus on the characterization of LSD's mechanism of action at a molecular level. So which receptors are needed for LSD to produce these robust behavioral effects? Next, it's to extend our results to models of mental illnesses in mice. So there are a wide variety of mental illnesses that are characterized by impaired sociability, and these mental illnesses can be easily modeled using transgenic mice in mice. And so we seek to study this. And lastly, it's to perform more electrophysiological experiments in order to further understand exactly which neural circuits and which brain regions are fundamentally involved in these sociability promoting effects of LSD. So thank you, Ezgi, for emceeing this, and thank you everyone for listening.
Thank you, Tommy, for the wonderful talk. That was really interesting. We already have 3 questions, so I will start with the first one. What was the sex distribution of the mice within the experiment, and were any analysis conducted with regard to sex-specific differences?
So that's a great
that's from Rob Taylor. Yeah.
Thank you for the question. That's a fantastic question. And because this was more of a pilot study to first identify any behavioral effects of LSD, we only used male mice in the study. But using both female and male mice is absolutely something we envision doing in our lab, because I agree that using female mice really isn't the norm necessarily in a lot of science, which is very unfortunate because there are fundamental sex differences for pharmacological effects, behavioral effects. So I absolutely take the question is well taken, and I will absolutely direct future research in that regard.
Thank you. Thanks also, Rob, for the nice question. Second question is from Marta Havenit. Marta is asking, were there any aggressive interactions at all in the social interaction test? And if so, did you see any differences between groups?
So thank you for the question. In fact, we didn't see any hyper-aggressive behavior. I mean, mice in general do fight, especially when they're put in a novel environment and they're trying to gain this, this dominance for this new cage. But LSD really didn't have any significant effect that would make it something worth exploring. It really wasn't anything robust. But that's a great question, and especially interesting because some of the models we're looking to study, hyperaggression is something fundamental in that mental illness. So it will definitely be involved in the direction of this research.
Okay, thank you. Also, thanks for the question. Another question is from Jacob Cheeseman. If mice prefer novel social interactions and LSD increases sociability, why do mice not self-administer LSD?
Very interesting. So, I mean, I don't know if there's been studies using, I forget what the behavioral assay is, where they can self-administer whichever drug. But actually, some of the old research, some of the pre-1970 research showed that LSD can actually be anti-addictive. So they were using psychedelics to actually treat addictions to drugs of abuse, so things like nicotine and alcohol. So in terms of perhaps the molecular or pharmacological effect, why this happens, I mean, I don't know why it's anti-addictive or why it's not addictive, but it's absolutely, I think, something that this field, a direction that this field is heading. It's to understand why this drug can be used to combat addictions.
Okay, thank you. So there is one more question.